Hi guys, today we're going to learn about conservation of energy. Energy is this really important thing in physics. It has a really important law, which is that it cannot be created and it cannot be destroyed. So this is the conservation of energy. However, energy can be transferred from one form into another. So it can be transferred from kinetic energy into gravitational potential energy. It can be transferred from chemical energy into, elastic energy. So there are loads of different ways in which energy can be stored, and we discussed that in the previous video. So if we look at a car engine and we think about what happens when you put fuel in your car. So you go to your gas station and you're going to put some fuel into your car. So that's your car. And then you're going to get some sort of movement coming out. So the thing that you put into your car is this fuel, which is a type of energy. Pause the video and think about what type of energy that could be. Okay, hopefully you've unpaused the video and you found out that indeed it is chemical energy. So chemical energy goes into your car and then it produces this movement. And remember, energy due to motion is kinetic energy. So you go from chemical to kinetic energy, and that is an energy transfer process. So this is a rather simple model because it's only looking at the useful energy that is produced. So it's only looking at the fact that chemical energy goes directly to kinetic energy and there's no energy that is wasted. However, this is not true because energy does indeed get wasted. And what is wasted energy? Wasted energy is energy that is sort of transferred to the surroundings, because remember, everything sort of gets spread out and goes around, and it gets transferred to the surroundings and spreads out so much so that you can't do anything useful with it anymore. So in this case, what type of energy do you reckon is wasted from chemical to kinetic energy in a car engine? So as you put in the fuel, is it only motion that gets produced, or is there sound? Is there heat? I mean, sound and heat that doesn't need to be there. So sound like a honk or a light from the lights. Those are all useful forms of energy. However, there are forms of energy which aren't so useful. Pause the video and think about what the not so useful energy types are. Okay, hopefully you've realized that as you put in energy, fuel, chemical energy, the car engine will become hot, and this heat is wasted to the surroundings because as you touch the car bonnet, you'll notice that it's relatively hot. Similar to your iPhone when you are, or your phone or whatever, when you're playing with it too much, it kind of gets a little bit hot because it's getting overworked, and that is energy that's wasted because you don't do anything useful with the heat energy produced from your phone. So let's talk about ways in which we can reduce energy transfers, so the energy wasted in energy transfers. Okay, so first let's look at an example of where energy is wasted, and something relatively simple like your house. So if this is your house and you have a door and a window and your roof and your walls, so energy is wasted through heat all throughout your home. So through the roof, through the window, through the door, through the walls. So let's say that you have 1.1 kilojoules per second of energy transfer out the roof, and you have 0.8 kilojoules per second through the window, and No, yeah, 0.7 kilojoules per second through the door and 1.7 kilojoules per second through the wall, sorry. Now, if you add up all of these things, what are you going to get? You're going to get the total of something. Pause the video and let me know what you think I'm going to get if I add up all these things. Is it going to be the total energy? Is it going to be the total force? Is it going to be the total power? Just take a look at the units and try and work out what you think it's going to be. Kilojoules per second. Okay, hopefully you've unpaused the video now. So I hope a lot of you know that it's power. These units represent power, because power is energy transferred divided by time. And energy transferred is in joules and time is in seconds. And if you do unit analysis, power is joules divided by second, which is joules per second. So yeah, if you add up all these things, 1.1 plus 0.8, 1.9, 1.9 plus 0.7, 2.6, 2.6 plus 1.7, you should get that the total power is equal to 4.3 kilojoules per second. So these are the typical questions that you'll probably get in your exam. So asking you what the power is, what the energy is, what the time is. So using the idea that energy isn't efficient, 100% efficient. And so looking at energy transfers. And this is all based on the conservation of energy. The fact that energy cannot be created and it cannot be destroyed. However, it can be transferred from one form into another. So just a fact to leave you with is that in a light bulb in your house, unless you're using like a fluorescent one, a typical light bulb only uses 10% of its energy to produce the light, whereas the rest of the 90% produces the heat. So a lot of it is wasted due to heat, and that heat you can't really do much with it because it's so spread out to the surroundings that it's no longer useful. So yeah, that's a good thing to leave on. I mean, not so good because energy's wasted, but it's a thing to leave on. I hope you've enjoyed the video and let me know if you haven't understood anything about it. Okay, cool. Thank you.